Inheritance is an object-oriented technique for sharing functionality between related classes. This video is an introduction to basic inheritance. Suppose we were designing a school information system. Two of the classes we would need are student and faculty. While a real system would need a lot more information, let's suppose that these are the things we need to store, and these are the things our objects need to be able to do. You can see that there's overlap in the instance variables and in the methods that the classes need. However, there are significant differences, so we will need two classes. One strategy for dealing this would be to copy and paste the code from one class to another. That's a terrible solution for a bunch of reasons. If we make two copies of the code, then we have to remember to make changes in two places. And if there is a bug in one place, we have to remember to fix it in the other. Basically, the more code we have to maintain, the harder it is to keep the system functioning well. So instead, we would like to structure the code so that we can put the common things in one place, and both the student and faculty classes can use it. Remember, a long time ago, we said that the word class had three meanings? One of those meanings was a set of objects of the same type. So in our system, we'd have a set of objects that are students and a set of objects that are faculty. In math and in real life, those sets could be subsets of a bigger set containing people. Similarly, object-oriented classes can have subclasses, so we could have one class for person and subclasses for student and faculty. In our case, student and faculty are subclasses, and the person is the superclass. But there are other ways that we think about it. The most apropos of these is that student and faculty are specializations of the general class person. However, we say that a subclass inherits functionality from its superclass, so we also think of the subclass as a child or descendant of a superclass, which is the parent or ancestor. The classes that we build reflect that inheritance relationship. In the UML class diagram, the open-headed arrow is used to show inheritance. So this diagram shows a student class and a faculty class, both of which are subclasses of a person class. The instance variables and methods that student and faculty both had go to the parent class, and the things that were unique go in the child classes. Coding that is pretty easy. We just mark the child class with the class it inherits from. In Java, you can only inherit from one class, so this cannot be a list. You already did this when we were playing with zip codes. We declared zip coding exception to inherit from exception. That's because it is a specialization of exception, and you can only throw classes that are children of exception or exception itself. Once we have set up the inheritance relationship, objects of a subclass get all of the instance variables and methods from the subclass, and they also get some of those things from the superclass as well. The modifiers that we put on the instance variables and methods in the superclass control what gets inherited. While I've listed the rules here, the details are beyond the scope of this class. Mark your instance variables and methods as protected or public, and we'll worry about the details next year. So, this is how I would design this part of our school information system. Just to be sure you see what is happening, when we create a faculty object, it will have 4 instance variables and 4 methods. When you do inheritance correctly, the relationship between the subclass and the superclass should feel like an is-a relationship. A faculty member is a person, believe it or not.